In this lesson, we are going to use completing a square to convert a quadratic relation from standard form to vertex form. Before we convert from standard form to vertex form using completing the square, we are going to review what we have done to find the vertex from standard form by factoring. So this is a standard form y equals ax squared plus bx plus c. A is 1, b is negative 2, and c is negative 8. For factoring, we could use a x game, 3 terms, then times together the two numbers. We are looking for two numbers times together equals last term, the c, add together is b, negative 2. So we find the factor of 8, we are able to find is 2 and 4. The larger number need to be same as the sum, so it's negative 4. And times together negative, another one need to be positive 2. So this is a simple trinomial. The a value is 1, no numbers at front of x squared. We could write it as x times x. Then you have x squared. The two numbers we found, we could put inside the bracket right away. This is a factored form. 2 times negative 4 give you negative 8. Plus 2x minus 4x give you negative 2x. So it works. And from this factored form, we are able to find the zeros of x-intercepts. And they need to be opposite with a number inside the bracket. So negative 2, 0, and positive 4, 0. We sub in the 4 here. 4 minus 4 give you 0. 0 times anything give you 0. And the same thing, negative 2 plus 2 give you 0. So 0 times anything give you 0. So from this negative 2 and 4, it means on this problem we have the two x-intercept, negative 4 and positive, negative 2 and positive 4. The vertex will be at middle of these 2 points because it's symmetric points on the problem. So the midpoint of negative 2 and positive 4 is the average of these 2 points. The x-coordinate add together divided by 2. So negative 2 plus 4 divided by 2 will give you positive 1. Then we want to find this is a vertex p value, the x coordinate. Then we want to find the y value. Most of the time when we want to find the y, we do the substitution. We sub x into this expression, then y is isolated. We could find the y right away, and the y for vertex is q. So q equals, we put the 1 to the factor form, or we put 1 to the standard form, replace the x with 1. So if we put in the factor form, we have 1 plus 2 times 1 minus 4. If you have factored form, I will encourage you to use factor form because you could double check if your vertex, the x coordinate, is correct or not. If it's correct, in the factor form, these two numbers should be same but opposite because it represents the distance from the x-intercept to the vertex. So one is back on negative 3, another one is positive 3. Then we are going to have the negative 9. So it means the vertex is at 1, negative 9. So this is what we did before. If the standard form is factorable, we could find the two zeros, then find the midpoint. Then from the midpoint, we sub the x value into the original or factored form. Then we can find the y value. So in this lesson, we are going to see if a quadratic relation is not factorable, then how are we able to find the vertex, convert it to vertex form? So y equals a bracket x minus p bracket squared plus q. This is your vertex form. So in the vertex form, we see there's no x term, it's a perfect squared. So we want to practice on how to factor a perfect square. So this one, we could use the x game. Times together is the last term, or you could times a and c together. The a is 1, so it's same, it's 25. I together is 10, then you will see it's 5 and 5. We have the two numbers same, so it means x plus 5 times x plus 5, it is perfect squared. So we do the same thing to the second question. So times together 9, I take together negative 6. You will see you have 3, 3, both need to be negative. They are same, when then we could have x minus 3 bracket squared. From these two questions, we find out that in order to have these two numbers same, you need to have these two numbers to be half of the b value. Then these times together need to be half of the b value squared. So this is half of b value, and the last term need to be half of the b value squared. So this is a pattern from these two questions. So half of negative 6, then half of negative 6 squared is a number you need to have in order to get a perfect square. So for example, I give you question C, x squared minus 8x. Which number we are going to put here to get a perfect square? We could do the backward of the x game. So we have two numbers x that is negative 8. Then we need to make sure we have the two numbers same, so it will be half of 2. Then the two numbers add together will give you negative 8. Then times together, we need to have negative 4 times negative 4 is 16. If this number is 16, then times together 16, add together negative 8, we know it is x minus 4 bracket squared. And this is a method we are going to use to complete the square, to convert the standard form to vertex form. So this is an example, x squared minus 2x minus 8. We want to focus on the first two terms, x squared minus 2x. Then we want to go backward. I together is negative 2, then we want to find which number I here we could have a perfect squared. Perfect square means the two numbers need to be same, so they need to be half of negative 2. It's negative 1, negative 1. They are same. Add together give you negative 2, then times together give you positive 1. So we need to have positive 1 here. So x squared minus 2x plus 1. Two numbers times together 1, add together negative 2. You have x minus 1 bracket squared. That is from this x game. But we don't have negative 1 from the original expression, so we are going to plus 1 minus 1. Then we have 0 here. We copy the negative 8. So this whole expression, they are equivalent. Plus 1 minus 1 give you 0, then minus 8 is your constant. But after we add 1 minus 1, we group the first 3, it gave you the x minus 1 squared. So we have minus 1 minus 8 left. Then we combine these two, we are going to have x minus 1 bracket squared minus 9. Then this is a vertex form. The vertex is opposite with number in the bracket is your p-value, then plus q. Q is negative 9, and pq is your vertex. So 1 comma negative 9 is your vertex. So this is one method that we go backward, add 1 minus 1, then the first 3 terms is x minus 1, x minus 1. Then minus 1, minus 8 outside of the bracket. We collect the like terms, then you will have the vertex form. Another method I want to show you is the box method. So we could draw a box and we are going to put it in bracket and the minus 8 is outside. So first term is x squared. We split the negative 2x to half. So it's negative x, 1x, negative 1x. Then we factor the first row. The common factor is x. We do the division. X squared divided by x is x. Negative x divided by x is negative 1. Negative x divided by x is negative 1. Then we could see this is x minus 1 bracket squared. Then the problem is we don't have a number here. We need to put plus 1 here. Then this is x minus 1 bracket squared. And in the bracket, inside the, so we are going to rewrite that expression here. So x squared minus 2x, and we put a constant outside. So in the bracket, we don't have constant 1 there, so we are going to minus 1. Then we have 0, so it's equivalent. Then the minus 1, we didn't use it, so we are going to combine it with negative 8. Then we have minus 9, so they are same. So you could pick method 1 or method 2, which one you like. This is box method, and this one is kind of like traditional method. Just rewrite plus half b squared, then minus half b squared. Then we combine the half b minus half b squared with a c value, that is your constant q. Okay, so this is the first method, this is second method. And after that, we are going to just practice. So this one, we could use the first method. We just go backward, add together 4, then we split the 4 to half, then times together these two numbers is 4. So it means we are going to have x squared plus 4x plus 4, then minus 4, then minus 8. So the first 3 terms is add together 4 times together 4, you have x plus 2, x plus 2, you factor 8. Then the minus 4 we didn't use, we combine 8 with the negative 8, you are going to have x plus 2 bracket squared minus 12. So this is a vertex form, it's done. Then we are going to do the next one. So add together negative 6, we go backward, split it into half, negative 3 times together give you positive 9. So we have x squared minus 6x, we need positive 9 here, then minus 9. Make sure put a constant outside. So the first 3 terms is x game, give us x minus 3 bracket squared minus 9 minus 8. Combine, we are going to have x minus 3 bracket squared minus 17. Then it's done. So continue example. Then this is a show you the box method is draw a box and put it in bracket. Put a constant outside your bracket. So in the box, x squared put in the first box, split the minus 8 to half, minus 4x, minus 4x. These two numbers must be same. Then we could have x minus something, same thing squared. So factor it, xx, then divide negative 4, divide negative 4. So x minus 4 bracket squared. But we need a number here to make it x minus 4 squared. So negative 4 times negative 4, always this is positive. Same number times give you positive 16 and minus 16. So minus 16 combined with plus 2 give you minus 14, then it's done. Then traditional method, we are going to go backward, minus 8, split it, we have minus 4, minus 4. Then times together need 16. So we rewrite the expression as x squared minus 8x. We want the last term to be 16. Then we could have x minus 4 bracket squared. And don't forget, we need to minus 16, then make this one 0, and copy the constant term here. So minus 16 plus 2 give you minus 14, then it's done. So after that, we are going to just practice more. And the next one, x squared plus 10x minus 1, we could use box method, or you could use a traditional method. So if it's box method, it's just draw a box, then put in bracket, minus 1, the constant right upside. In first box is x. The second one need to be half of that one. So we need these two numbers to be same. So half of 10 give you 5. Then x factor it, 5. We need to add 25 here to make it a perfect square, and remember we need to have add 0 here. 0 minus 1 give you minus 1. Then we write it, x plus 5 bracket squared. Then minus 25 minus 1 give you minus 26. It asks you to sketch, so we are going to sketch it. It will be extended somewhere. Okay, it should be the negative 26. So we are going to extend it. Somewhere, assume this is negative 6 and negative 5. Negative 26 will be somewhere here. Another point easily we can find is y-intercept. So negative 1 here. Then from this one is 5, comma, negative 5, negative 26. Then this is a axis of symmetry. The symmetric point of y-intercept will be on the left 5, so it will be around 10, negative 1. So you have these 3 points, then you could just connect it. Or right one up 1 a little bit, left one up 1 a little bit. Then you are going to have the graph, connect them together. Then another side. Okay. So this is once we have a vertex form, then you will see it's easier for us to graph it. We find the vertex, negative 5, negative 26. Then use a step pattern, a times 1, 3, 5. And this one, no numbers at front of the bracket means it's 1. So 1 times 135, it will give you 135. So it means right one up 1, right one up 3, right one up 5. So they are the slope from the vertex, right one up 1, right one up 3, right one up 5. The slope is changing, then make sure you will have a curve, non-linear graph. And if the slope is same, you will have a straight line. Okay, so this is for the a value equals 1. And part B, we are going to see if a value is not 1, then how are we going to convert it to vertex form? And this question asks you to determine the maximum and minimum value. So if you are looking for maximum, minimum, then if we could find the vertex, then you are able to find the maximum, minimum. Okay, for this question, it's different from a value is 1. So for such question, always we start with take the a value out, even if it's not a common factor. So x squared and 3 divided by 2, then x. We group the first two terms only, leave the constant out. Then after that, we could use a box method. So this is exactly same as a value is 1. We put x squared here, then split this one into half. 3 over 2 half will give you 3 over 4. Or you could just use a decimal, 0.75x, 0.75x, or 3 over 4. So most of the time, I will highly encourage you to use fractions, because sometimes if not divisible, then we want you to keep the exact value, then you need to keep fractions. So x squared, quarter, 3/4, 3/4. Then we factor it, x, 3 over 4, 3 over 4, then plus 1. So how to get 3 over 2 divided by 2 give you 3 over 4? We are going to do the 3 over 2, flip the division to multiplication will be 1 over 2. The numerator times numerator is 3 times 1. Denominator times denominator give you 4. So that's the reason half of 3 over 2 give you 3 over 4. Then after we put 3 over 4 there, you are going to see x plus 3 over 4 bracket squared. And we need to put something here and minus same thing after it. So 3 over 4 times 3 over 4 give you 3 times 3 is 9. Numerator times numerator. Denominator 4 times 4 give you 16. So minus 9 over 16. Then the first positive 9 over 16 give you the perfect square. The minus 9 over 16, be careful. If you have a value at front of the bracket, you need to times the a value with whatever inside the bracket. So plus 2 times negative 9 over 16, then plus 1. Then you could use your calculator to find out. Two times negative 9 over 16 plus 1, it will give you negative 1 over 8. And this is done. So this is for this question, and it asks you to sketch it. We are going to graph it. Negative 3 over 4. So this is we are going to change our mind. We are going to group the graph the next one. Graph B instead of A, okay? Because decimals is the fractions is hard to graph, okay? So we are going to do the second one. Second one, same thing. We are going to group the first two terms and take the negative 3 out. We want the x squared, no numbers at front, inside your bracket. Then after we have the negative 3 out, it will be same as what we did before. We could use the half b squared, the traditional method, do the backwards. So I together is 2, then split it into half, then times together, it gives you positive 1. So it means in the bracket we have x squared plus 2x. Then the last term need to be positive 1. Then minus 1. We are going to have it equal 0. By doing this, the first 3 terms is this x game. You have x plus 1, x plus 1, 2, positive 1 as your factor. So x plus 1 bracket squared. And remember, you have a value at front. You need to times this a value with a number that you subtract, then plus 4. You combine the like terms, you will have negative 3 bracket x plus 1 bracket squared plus 7. Okay, so we have the vertex p-value need to be opposite is -1, positive 7. Because a is -3, so we know it is open down. So we have a maximum value at vertex, that is your y value. So we are going to graph the b, okay, on the grid given. So -1, 7, and -1, positive 7 is your vertex. So -1, positive 7. Then after that, we are going to have the step pattern. -3 times 1, 3, 5 is the slope from the vertex. So -3, -9, -15. Then we are going to have red one down 3, red one down 9. Then do the same thing, it's symmetric, so left one down 3, left one down 9. Then connect them, you have the graph. And in this lesson, you need to know how you can convert from standard form. Standard form is y equals ax squared plus bx plus c. And make sure if a is not 1, you need to take the 1 out. Then in the bracket, we have 1x squared. 1x squared will make sure that we have xx, they are same. Otherwise, you have 1x, 2x is not perfect squared. So that's the reason we take the a value out. Then we add something half b squared minus half b squared, a times minus half b squared, then plus c to be your constant. Once we have the vertex form, it's easier for us to find the maximum, minimum value, and also it's easier for us to do the graph. So thanks for watching.